Hello everyone. Today I'll be walking you through my Java program which implements a model-based agent to detect the binary pattern 1001 within a given input string. So the goal of the program is simple. It takes a binary string which consists of only zeros and ones from the user and scans through it, and whenever it finds the pattern 1001, it marks that position in the output string with a 1. Otherwise, the output remains all zeros. I have designed the agent to allow overlapping detection as well. We achieve this using a finite state machine with the 4 states. First, let's go with the explanation of the FSM diagram. So this is the FSM diagram. Since my laptop doesn't support touch, I'm going to draw the diagram in my tablet using a whiteboard. You'll be able to see the same here in the Teams whiteboard. So consider we have 4 states. So since we are going to detect the pattern 1001, there are 4 bits are there. So according to it, we have 4 states. So at state A, we will be waiting for the input 1. So if 1 is received, then we will be moving on to B. In case if we are receiving 0, then we will be waiting at the same position until we receive the further input. So now we consider we received 1 and we are at B state, and there are two possibilities. The next input can be either 0 or 1. In case if we receive a 0, so we have to detect 1001, right? So in case if we receive 0, the pattern, the detection continues, and this is 0 by 0. What if we receive 1? Then we will be staying at the same position until we receive the next input. So now we are at C, and we have already found 10. Now we are waiting for the next input, which can be either 0 or 1. So if it is 0, the deduction continues and we will be moving on to the state D. So 0 by 0. In case, what if we get 1? So if we get a 1, that means 101. So the pattern can't be detected, and this one could be a new one starting for a new pattern. So we will be switching to B, and we will be waiting at B. So now consider we already received 100 and we are at D. So now the final input we are waiting for is 1. So if 1 is received, the pattern is matched and found. If we receive a 0, then the pattern is broken and we have to go back again to A to reset the search, and we will be starting from first. So if 0 is the last one found, 0 by 0, so the pattern is not found. So in case if 1 is received, that means pattern is found. Since this allows a overlapping detection, we are moving to B so that this one can be a start of another search as well. So this is how the FSM diagram looks. So sorry for the messy drawing here, but you can see the expected drawing here. The same drawing only I have explained it now in my whiteboard. So now let's dive into the code and understand how the code works. So this is the code I have implemented for the model-based agent. So now let's take a look at the main method which handles the user input validation. So basically we are going to receive the input string from the user. So we created a scanner object to read the user input. We use a while loop to continuously prompt the user for input until they enter a valid binary string. So in case if they are entering any values other than zeros and ones, our program will prompt the user to enter a valid value which consists of only zeros and ones. So we have included a if loop here, and if the input is valid, we break out of the loop. If the input is not valid, we will be prompting the user to enter a valid input. So once we get the input from the user, we go to the next step, which is our output. So in this particular step, we are calling our FSM method to process the input. So we are going to pass the input which we received from the user. And once we passed the input to the FSM method, once the FSM method processes it, finally we are going to print the output using a system out println. So now let's go to our FSM method. So initially we start with state A, which means the FSM is waiting for the first one to begin the pattern detection. So we have created a string builders to store our output. We have to print one in the output string only when the pattern is found. So only when the pattern is found, in the sense 1001. Only if it is detected, we have to print one in the output string. So until that, we assume the pattern has not been found, so we fill uh, the output with zeros. So we are using a for loop, and using this for loop, we are taking the input string character by character. At each position, we extract a character from the input string and process it based on the current state of the FSM. So now let's go over how our FSM transitions between states when processing each character. So consider we are at state A, and if we encounter a 1, we move to state B, and we will be waiting for the input 0. In case if we get a 0, we will be waiting at state A itself until we receive a input 1. Now at case B, which is state B, if we get a 0, we transition to C. However, if another 1 appears, we stay in state B. So state C, we are waiting for a 0, and once a 0 appears, we move to state D, and we will be waiting for the final one to detect and confirm the pattern 1001. In case if we receive a 1, we return to state B and restart the search. So once we are at D, we will be receiving the final one, and once we receive it, the pattern is detected, which is 1001. So we will be setting the corresponding position in the output string to 1. Instead, if we receive a 0, the pattern is broken. So we reset the FSM back to state A to start searching again. But what if 1 is received? So that means pattern is found, and since we are allowing overlapping pattern, we will be staying in the same state, and we will be waiting to detect the next pattern. So after processing the entire string, we return the modified output string to the main method. So now let's see how this works with an example. Suppose, so I'm going to run this particular code. So it will be asking for the user input. I am entering a user input, but I am entering some invalid characters. So the program is throwing an error and asking us to enter a valid input. So I'm just going to enter 1001. So once at the end of state D, once we have identified the pattern 1001, the output string output string enters the value as 1. So I am running the code again. So this time we are going to use a big input string 0, 1, 0, 0, 0, 1. 001, 001. So now our code is going to process this, and the output string, if you see, so initially once we received a 1001, our code outputs a 1 here, and then that one, since it's a overlapping method, again we are going to state B and we are continually searching for the pattern, and again 1001 is detected. Our program outputs a 1 at the end. So this is how the output string of our program looks. So that's how our model-based AI agent works using a finite state machine. This approach can be further optimized if you are going to use Python to write our code logic. However, I am more familiar with Java than Python, so I have gone with the Java coding for this. Thank you for watching. If you have any questions, please feel free to ask. Thank you.